Okay, so 8.5, finding the area between curves expressed as a function of y. So what's the difference there? Well, the difference there is that essentially the rectangles, if you can imagine, are lying down instead of standing up. But there are different benefits for either one, so we'll discuss that in a minute. But first, if you haven't done the do now yet, please do that now. You're solving for x in terms of y for each of these. I'll show you the answer. So pause the video and try. Sorry, it's just for A, my B's look like, my 6's look like B's, but it's supposed to be a 6. In this case, when we separated variables, we kind of practiced that a little bit, taking it out of logarithmic form. And then the same for part C here. Just keep in mind when there are two options, you have to pay attention. In this case, it says x is less than or equal to -4. So out of the two choices we ended up with, I'm picking the negative one because that would make this statement true. So that's what it's asking for there. Okay. So finding the area between two curves using horizontally oriented rectangles. Now the lower boundary will be down here at, in this case, -1, and the upper boundary will be at +3. And instead of having dx, I'm using this here is a dy. That's the width of each rectangle. And then we take the length of each rectangle is going to be the upper function minus lower function. But in terms of y, for both of them, right? So and let's think about that for a minute. If I'm trying to find on the xy coordinate system some horizontal length, I'm essentially finding, like, this is x sub 2 and this is x sub 1. I'm taking x sub 2 minus x sub 1. So I need the x coordinate minus another x coordinate here. Well, to find the x coordinate of the upper and the x coordinate of the lower, I would then need to solve for x, which would then be in terms of y. So it sounds a little counterintuitive, but the reason why the whole thing is in terms of y is because we're solving for x so that we take the upper x minus the lower x. Oops, I'm getting a text here. All right, let me just turn that off. So essentially it's the same thing as when we did it in terms of x, but now we're just doing it in terms of y. And instead of being upright rectangles, it's now lying down. Each of the rectangles are lying down. Now you could essentially do this problem in terms of x, but it would be much more complicated because I would have to do 3 sections of this. I would have to do this first section and then this middle section and then this last section. So essentially I'm doing, if I was doing rectangles here, this one happens to be a rectangle itself. So I would and then I would have to figure out, okay, what's the upper and then minus the lower. It becomes like a very complicated problem. So sometimes just doing in terms of y, like we have here, is much, much easier. So it just is a lot of times like, what are our better choices here? All right. Write an integral that represents the limit of the sum of areas of rectangles between the curves given. So now our job then is, I need to, first of all, here are my two functions. And just in terms of notation, up here at the top, f of y is given in terms of y. And then we have something, the g function is given in terms of x instead of y. So I just have to keep that in mind, that I have this in terms of x. That means I have to solve for x in terms of y before I can write the integral. So step number 1, I have all of the stuff here. What I notice is, first of all, just so you know, we're taking the upper f of y and I have to subtract the lower, which is g of y. but it's not written as g of y, it's written as g of x. So that means I'm going to go in down here at the bottom and solve for x in terms of y. That's how I'm going to get my g of y. So my g of y is right here, and my f of y is right here, which was the upper function. And my boundaries was from -2 to, I wrote 2 there by mistake. It's supposed to be a 3. Whoops. It's supposed to be a 3 here. Like that. Or you could do the area from the y-axis up to the upper function and the area to like similar to the x-axis. Other than that, it doesn't really change much. It's done exactly the same way. Some people like cheat the system a little bit and rewrite everything in terms of x and y and kind of switch it around. You could do that, but it's good practice to think in more than one dimension. Like instead of always going from x, you can also do it from y. And then I'm just going to put out here, we're going to do example 1 in a minute in the next video, but I'm just ahead of time